Good day, I'm Dr. T and welcome to my office. So the discussion of chemistry and art is a classic one that as chemists we always kind of enjoy talking about. There's tons and tons of books written. I just want to jump in with a bit of a primer on this one and hopefully whet the taste buds for a very interesting area of science, history, and art. So I'm basically focusing on visual art, so painting and the like. Obviously, when talking about chemicals, there's an insane number of chemicals, and when talking about types of art, there's an insane number of types of art. In both cases, too many to count. So kind of the basics, and if you're thinking prehistoric peoples, etc., you're starting from the basics. But we still do a lot of these today. So you want to make some art. You want to make a picture of some sort. Or color something, whatever you want to do. You want to make your visual arts. As you can tell, I'm a chemist, not an artist. You're going to need at least two things. The first is something to make your art on. I'm going to call that the substrate. And, a big rock, yourself, some paper, whatever you'd like. The next thing you're going to need is a colorant. A colorant is going to be a chemical that is going to be able to either absorb or in some way influence at least some visible light. This way, when light shines on the chemical, light is going to bounce off, but it's not going to bounce off in the same way that it shined onto the chemical. And your eyes are going to perceive that as a color. The classic way of doing this, what most colorants really are doing, but not all. There's some weird colorants. Most of what they're going to be doing is you're going to have the chemicals in there, and the electrons are going to be arranged around the atoms in your chemical in such a way that they can take a photon and take the energy from the photon and use that to temporarily rearrange the electrons within the atom. And very minor rearrangements. We're not talking fundamentally changing the molecule or the atom, just simply moving them to a slightly higher energy level, and then they will come right back down, and that energy will be dispersed in one of a few different ways. The end result, though, is that the light shining on the thing and the light reflecting off of it aren't the same. And once again, that gives you color. And for this, you could simply take a colorant and put it on your substrate. And if you're doing rock art with, say, some ochre, that's what you're doing. If you're writing with a pencil on a piece of paper, that's what you're doing. Now, there's a couple of things we want to kind of consider. For starters, your colorant can come in a couple of different forms, and I'm going to look at two of the major ones. First can be a pigment. These are typically, but not always, going to be inorganic salts or things that don't contain carbon, and they're not going to dissolve. So if I tried to mix them with some sort of solvent to help me transfer them onto my substrate, they're just going to form a suspension or a colloid. They're not going to dissolve. Alternatively, I could have dyes, and dyes are going to dissolve in a solvent, and I can use that to transfer it to my substrate. So think something like an ink pen. Typically, your ink pens are going to have dyes, although not always. It does depend on what form of ink you have. Carbon black is going to be a classic colorant in ink, and that's much more of a pigment than it is a dye. Typically speaking, pigments are going to give you a little bit more of an opaque color than dyes will. Okay, so you've transferred your colorant onto your material, but sometimes it doesn't stick. You know how clothes can bleed? I once had this wonderful red shirt that would turn anything white that it got next to pink. It would turn your undergarments pink. It would turn the clothes in the laundry pink because the dyes didn't stick to it particularly well. And that's a classic problem with dyes. Sometimes the dyes will chemically bond with the substrate. But a lot of times they won't, and as such, you need something to help them stick to the substrate. So you got a couple of choices. First, you can use a mordant. A mordant is going to be something that takes the colorant, whether it be a dye, and typically they're used with dyes, that's going to take the dye or the pigment, and it's going to chemically bond it to the substrate. And so this would be quite often a classic additive when dyeing fabrics, etc. You'd have the fabric, you'd have a mordant, you'd have a dye. One goes on the other kind of thing. order depends on which ones you're using. And this way your dyes stick to the cloth. And this is a great way to make a nice color-fast dye. Mordants can come in all kinds of varieties. And a lot of modern dyes don't particularly need a mordant. They're able to chemically bond to the fabric of choice. Now, an alternative to mordant is going to be a binder, and binders are going to be more often used with pigments. And what binders are going to be doing is they're not chemically binding the colorant to the substrate. Instead, they are physically gluing it on. So if you think of crayons, crayons are going to have a wax binder. And so you've got your colorant, it's mixed in with your wax, and you rub that on whatever you're coloring with your crayon or your colored pencil, etc. And the long carbon molecules in the wax are not really going to want to slough off very easily, and thus the colorant is intermixed with them, and that adheres everything on there. So that gives you a binder. Now, not all binders are going to be just simple big molecules that go onto your substrate. Traditionally, the classic paints would have been made with either a tempera paint, which uses egg yolk, or later on oil paints, things like linseed or walnut oil. And these are going to be what we call drying oils. So within the egg yolk, there are lots of triglycerides, and many of those are going to be polyunsaturated fatty acids. Linseed oil and walnut oil are rich in polyunsaturated fatty acids, and certain polyunsaturated fatty acids are what we call drying oils. They are going to be able to chemically react with oxygen in the atmosphere, and as such, they are going to start to actually polymerize, and they're going to start cross-linking themselves. This way, not only are you having large molecules sticking things together, but you are actually making it into a very, very large molecule that's intertwining with the substrate such that it's not going to want to come off very easily. Now, obviously, things do come off. Art historians and curators of museums, etc., talk about self-sampling paintings, ones where the paint just kind of sloughs off. So, you know, nothing is forever, nothing is permanent, but, you know, we can make it last longer or not. Now, of course, the 20th century has brought in a multitude of chemicals that we can use, many more colorants than we once had, new binding agents, new mordants, dyes, and pigments that don't need those. And then, you know, other options. So typically speaking, when we're thinking of a you know, an artistic medium, something that we can put on our substrate, typically we're going to think about it as having a colorant or colorants, a binding agent and or mordants, and then a solvent, just to make it easier to work with. So if you have, say, some dry erase markers, you know, nothing screams 20th century more than dry erase markers. Okay, a few things, but, you know, they're very, very characteristic late 20th century. These are going to quite often have a solvent that's readily evaporating, colorant that could either be a dye or a pigment, and then a binding agent that's really kind of cool. It's one that will form a film, but it doesn't bite into the dry erase board. It will slough off with just moderate rubbing. And so with your very smooth dry erase boards, you put your dry erase marker on it. The solvent evaporates off very, very quickly because it's a tiny molecule, and it leaves the binder and the colorant intermixed on a layer, but it's a very fragile layer, so you can just simply erase it with, you know, a piece of cloth or some felt or some whatever you are erasing your dry erase board with. So it leads to, you know, an interesting form of art, very ephemeral by design. So with that said, really hope you dive in and look at the history and the chemistry of art, as well as the art of the art. And have a wonderful day. I'll see you in other videos.